welcome to my workshop. Every day I have either emails or comments on one of my laser videos asking me whether my 100 watt CO2 laser can engrave in metal. Well, the short answer is no, it cannot. If you try to engrave metal, you do stand the chance of damaging your lenses, and it's just not powerful enough to penetrate into the metal. What restricts it is a thing called energy density. That means you have 100 watts and it's concentrated into the size of a human hair nearly, and it's just not quite enough to penetrate into metal. Metal is very reflective to a laser. What you can do with a CO2 laser on metal is remove paint from it to reveal the metal underneath, or you can coat the metal with a ceramic paint compound, and when the laser travels over that compound or paint, it melts that paint, the ceramic paint, to the metal, and it's permanently on there. You can then clean away the remaining residue paint that hasn't been melted on by the laser. Okay, so now I'm going to show you a laser that can etch any metal, including gold. So this is a fiber laser. The actual laser itself is housed in this box that's slightly bigger than a computer cabinet, and this is the galvo head and adjustment mechanism. Inside here there's two mirrors that move extremely quickly, and this is a lens that directs the beam down onto the work. Now this particular laser is a 30 watt fiber laser, but don't let that fool you, because that 30 watts is magnified up to about 24 kilowatts. That's how it can, well, if you want, cut through stainless steel. Now, I'm going to give you a short demonstration of the power of a small but pretty powerful fiber laser. Okay, so this is the program that runs a fiber laser. Now this is called EasyCAD 2. It's fairly simple to use, however it does have its own peculiarities being a fiber laser, and I'll just demonstrate some of those now. So we're going to come over here and we're going to pick a circle, and we're just going to draw it in here. I'm going to come over to this side and we're going to assign a diameter of 15 millimeters and press enter. Now you can see it jumps to 15 millimeters. Now the lens that I have in at the moment is a 110 by 110 millimeter focal lens. So this square area here is 110 millimeters square, as you can tell by the rules. Okay, now I am just drawing this circle because I'm going to drill a hole in a piece of shim stainless steel. Now, to do that now, we've drawn our circle. We need to come over to this side. It's on a black layer. Same as any other laser program, you work with layers. So we're on the first layer. So now we're going to assign an output for the fiber laser. So we don't want to use the default, so uncheck that. This doesn't really matter to us. That's sort of saying just do one cycle. But I can change it down here to continuous if I wish, and we do wish. Speed, we're going to say 1000 millimeters per second, so it can move pretty fast. This particular one can go up to 5000 millimeters per second. Let me see, power. Well, as we're going to be drilling a hole, we're going to say 95%. Now, this is the one that a lot of people get confused with. Now, frequency. The lower the number the frequency, the higher the output in power in relation to this percentage power here. Now, if I put 80 here, which is the highest number of frequency, it would still be at 95%, but it wouldn't damage the material as badly as it would at 20,000 hertz. So we're going to leave it at that. This is not necessary to alter these at all. Those are the three main ones there. So now the laser will operate at that level. So now I'm going to set a piece of material up and we will cut through it. Okay, so I've got a piece of stainless steel here. I'm just going to measure it for you. So it's 0.09 millimeters. So that's 3.5 thou. Okay. Right. So we're going to set it on here like this, because I want an air gap underneath, and it's very important to get the measurement right underneath the lens. Now, with this particular lens, it's necessary to be exactly 167 millimeters above the surface of that material. It is crucial you have about half a millimeter. You have a half a millimeter play. That's all you have between it doing the job and not doing it at all. It's very crucial to get the correct measurement. I've got the red dot laser on now showing me where it's all going to happen, right there. Now I'm going to bring the camera in the front and underneath slightly, and you'll be able to see it go through pretty damn quickly. So, if I can hold these. So that was a very quick demonstration of, very quickly, a fiber laser punching a hole through some shim stock stainless steel. So I think you can grasp the amount of energy that a fiber laser can actually punch into a small area, and the way in which the galvo head, that's what this is called, the galvo head mirrors can actually focus at that laser beam and, you know, draw a circle and just punch a hole straight through. A matter of seconds to go through that. But you don't normally buy a fibre laser to do party tricks like this. What this fibre laser is primarily used for is marking. When I say marking, I mean putting a barcode into something, or for our next demonstration we have a high-speed steel or tool steel drill here of 13 millimeters, and we're going to engrave into tool steel. This is going up quite a few notches from you know, thin shim stock stainless steel. This is a lot harder to get into, but fibre laser, not a problem. So I've gone into EasyCAD and I've pulled up the text menu and I've just written 13mm HSS, which is the type of tool steel that it is. So we're done with the size of this. Now let's highlight that again. The size of this is 3mm high, and it is just over 12.5mm in length. So it's quite small. So we're just going to put that down here, out the way. Now we're going to come to the hatch. Now, a lot of people have problems with hatches. A hatch is just the letters. The letters I am going to fill in with scan lines. So it's called hatching. That's all you're doing, is putting scan lines in. Now, the particular method of scan lines can vary. This is a radial, in other words, it'll start on the outside of the lettering and work its way in. Probably we may use that. This is called unilateral, in other words, it will scan left to right, come down to the next line, then scan right to left. So that's unilateral. Well, that's unilateral, but sort of dot dash. Now this is what's known as bilateral. So it scans in one direction only. So it's scan that way, switch off, come here, scan again, and scan again, and scan again. This particular job we're going to use, I think, we're going to use a bilateral. Pen, black layer pen, all calc. Now what that means is the laser's going to switch on here, fire as it runs through the letter, and switch off, and then fire again in the middle of this letter, or in this letter. If you don't tell it all calc, it will fire through here, and it could come up here slightly. It won't be in a parallel path. So this just makes sure that it is in a parallel path. Now this is the step over of the scan line, which is 0.01 of a millimeter. I think we're going to narrow that down a little bit further. We're going to go 0.5. So quite tight, because it's tool steel. So you want to get quite a number of pulses into those letters to gauge the material out. Is this angle? I've got a choice of doing 3 separate hatches, which we will do. So for hatch 1, we're going to be in a parallel, okay, straight across. Nothing else to fill in here. It's enabled, so it's actually going to carry it out. If you don't have this enabled ticked, it won't do anything. Okay, that's that one. And hatch 2. Unilateral, I think we'll do a unilateral, yes. And we'll do that at 45-degree angle out and come through, which is fine, but again we need to alter this setting to a 0. And then hatch 3, that's also on a black layer. We don't want to alter the layers. This is minus 45, so we got one doing parallel, one coming in at an angle of 45 degrees that way, and we'll have this one coming in at an angle of 45 degrees that way. That way it eliminates any scan lines, or it ensures you get a good coverage, and it'll do it in a matter of seconds, so it's not sort of time wasting as such. But again, we need to put a 0 in there. But I've got all at the same scan line distance. And we're going to OK that. So notice now it's all gone black. It's coloured it in. So it's accepted that, OK, it's a hatch. So now we come over here. It's the black layer. And we're going to turn the default off. And I'm going to do 100 millimeters per second scan line, and we're going to go again 90% power for this, 90% power, and 20,000 hertz is fine. We're going to be putting this into tool steel, which is really, really tough. The only toughest material than this is carbide, and one day we'll give that a shot as well. So I'm happy with all that. So now let's set up the drill underneath the laser head. Okay, now again, it's crucial to set the lens up exactly, in the case of this lens, which is a 110 by 110 focal, if I can get here, needs to be exactly 167. That's it. Okay, so I'm just going to highlight that now. And I can move that to get it just right. It's right there. Okay, let's see if I can get it better. Can't get it any better than that, I'm sorry. Okay, here we go. We're marking. And that is the end result. Now that is really deep into tool steel. Now I'll just clean that up a little bit with a wire brush, and you'll be able to have a better look. Okay, I think you can pick that up. 13mm HSS, and that is really, really deep. I don't know whether the camera can actually pick that out, how deep that is, because it's been so shiny and goes really deep. Okay, so I don't know whether the camera can pick that up and really do it justice, but it is really deep, and I actually don't have anything to get in there to measure how deep that is, but you know, at a guess I would say it's between 0.2 and 0.3 of a millimeter deep, those letters. Now I purposely ran the laser, or set the laser's settings so it would run for a considerable amount of time to get a deep etching in tool steel. And of course, in reality, the fiber laser would etch that sufficiently to be a permanent mark in about 5 seconds. So this was just a demonstration of really etching into tool steel. And I hear you ask, oh well, what's the good of that? We don't need to mark drills or anything like that. Well, this is really just a demonstration to show you, well, it will mark tool steel or any other type of metal you put under it. And the type of work that you can do with a fiber laser, if I can make an example, if you can think of a decorative jeweled charm that someone would have around their neck, you don't really think that someone really carves that out, do you? It's done with a fiber laser. Same thing with rings, yeah? You know the lettering on the inside of a ring? Fiber laser. That's what does it. So you can imagine, you know, like a shall we say a silver fob, you know, the type that opens and you have a photograph of your loved one in it. Well, I wouldn't wear one, but you know, many women do. And when they're shut, there's a beautiful design carved in silver. Fiber laser. That's what does it. And this weekend, hopefully this coming weekend, I am going to take this beautiful brand new Zippo lighter that has a solid brass case, and I'm going to carve a design in the faces. Okay? Now it could be anything. It could be anything metal. It could be gold. Okay? It could be anything. But I'm going to show you over the coming months and years exactly what a fiber laser can do. And this really is in answer to, you know, everybody that's written in saying, well, will a CO2 laser engrave metal? A fiber laser will. Now, there's a couple of different fiber lasers. This one is a standard 30 watt. And it will, it will do everything that I want it to do. There's also another type of fiber laser that's called a MOPA fiber laser. Now that bad boy, you can just dial in a frequency and it will etch a colour that you desire. It's all done with the frequency. A certain frequency gives you a certain colour every time. This one, this standard fibre laser, it is possible to etch or engrave colour, full colour, but it is very, very difficult. You've got to get it absolutely right, and you actually have to take it out of focus to be able to do it. I have done it. I have videos that I did last year with this laser doing colour, but as I found, it is very difficult to get right. And also I've noticed, I'll answer the question now as we're talking about fibre lasers. I've had a lot of people say to me, but that's only 30 watts. How can it engrave steel? Or how can it engrave metal when a CO2 laser won't? I'll explain very quickly. This fibre laser has 9 diode lasers, very different to the diode lasers that you will see on little 5 watt diode laser. Very different. These are industrial diode lasers, so there's 9 of them. They're all fired together. They're called pump lasers. Then there's another 3 that are called seed lasers. Now I'll just explain. A CO2 laser works in millionths of seconds. The fibre laser works time frame, its operating time frames is measured in billionths of seconds. So what happens is the 9 pump lasers are going all the time, and they are, should we say, filling up. Okay, there's a coil of fibre optic, similar to your phone line fibre optic, but much different, much heavier, and it's got a reflective coating on the inside, and it's much more, shall we say, robust. So these 9 lasers are going all the time, pumping laser energy into the system, and then the control or seed lasers fire, which overpower the system, and out the laser comes. Okay, so as you see the laser there, it's not on all the time. It sort of pulses on, off, on, off, on, off. So the off period, the pump lasers build the energy up to a maximum of 24 kilowatt. Then it all lets it out in a surge. That's how it does it. That's how it's able to cut through stainless steel and gouge out tool steel. That's how it does it. Now, how I've explained that is very, very layman and very simple, or simple terms, so everybody can understand. It is very much more complicated than that. And over the coming months and years, I'll try and explain a bit better. But for this coming weekend, the next fibre laser video, we are going to take this brass Zippo lighter and we're going to engrave a pattern, maybe some writing on the sides of this solid brass, okay, or solid brass casing. Again, as a demonstration, but this can be turned into, you know, zipper lighters as standard and not cheap. Okay, I think this was something in the region of $50, something like that. But by the time you put a customized pattern on this and maybe an inscription, happy birthday, whatever, you can turn that $50 and double your money, and that Fable laser will do it in seconds. Should we say a minute aside, something like that. So it's possible, right? You know, if you take a sort of 10 minutes of CAD CAM work and then operating time, you can actually make $50 in 10 minutes. It's possible. You can do it. But, you know, you're not going to do that every hour of every day. So I can show you one type of item, and I will show you many, many more over the coming months and years. So, thank you for joining me for this video, and I hope you've enjoyed it. If you've got this far, you probably have enjoyed it. So please press like and subscribe to the channel. That's one way that the channel grows. If you really wanted to, you could buy me a cup of coffee by hitting the button down there with the heart on. And you can go in there and pledge a $1 if you wanted to, buy me a cup of coffee. Or you could become a regular patron and help the channel in that way. And it is the patrons behind the channel that allow me to make videos like this with this high-tech equipment. So thank you for joining me, and I hope you tune in again to see one of my other videos or my new videos. So it's bye for now.